Let's start by just thinking about a regular old problem that we've been doing. Monica has paid $10 for travel costs, then she earns $12 per hour for catering. How many hours will she have to work on one shift to earn $70? How many hours will she have to work? That's what we're trying to find. So that became our X. And we always ask the question at the beginning of the problem, well, how many hours did she work to earn $70? The answer is X. It's a number. We don't know what the number is yet, but we'll figure it out. But we can then use that number to relate everything together. She's going to get paid $10 an hour. $10 for travel costs, then $12 an hour, so we multiply it by whatever that number is that represents the hours, and it equals 70. And then we go ahead and solve, we subtract the 10, we divide by 12, and we're going to get 5 if she works 5 hours. Well, now we know what the number is, but we just had to represent that unknown number with the variables so that we could manipulate the problem and find our answer. Variables are numbers. Now really, variables are numbers. That's the important thing to remember. They behave like numbers. We get rid of them like numbers because variables are numbers. So, but they may be numbers for which we're uncertain about their value. This is the area formula for a rectangle. Right now, if we said, how much is h worth? Well, I don't know. I'm not sure. Well, what if instead we said that we know area was 56 and we have this. Now what's h worth? We still don't really know. Well, okay. What if I tell you that we have this thing right here? Now what's h worth? Oh, now I can figure it out because I'll divide both sides by 7 to get the variable by itself, and I'll get that h is equal to 8. But wait a minute. We can still know what h is worth up here because variables are numbers. That b could be a number. We don't know what it is. Could be 7, could be 8. We don't know. But it's a number and it behaves like a number and it's being multiplied by h. So just like we got rid of this number that was multiplied by h by dividing by that same number on both sides, we can get h by itself. We can solve for h by dividing by that number b. And so b divided by b is 1. And so what we end up with is 1h, which is just h, is equal to 56 divided by b. So we can say, there it is. There is our relationship. We know that that is what h will equal, 56 divided by whatever b is. Once we knew what b was, look, we do 56 divided by b, and we know exactly what the number for h is. But this gives us a new formula where we've solved for h, and we can still say what it's worth in terms of another variable. So literal equations, they have few, if any, actual numbers, but variables are numbers. So when we solve for any one variable, we're just undoing unwanted numbers or variables by going reverse order of operations. So this guy here, what if we said solve for time, because that's distance equals rate times time. So solve for t. Okay, well, let's think that through. This number, r, it's a number. We don't know what it is yet. It's a rate of travel. Maybe we're traveling 80 miles an hour down the freeway. Maybe only 60 miles an hour, right? Maybe we're on a horse. We're only going 20 miles an hour. But to solve for t, we got to get rid of this number that's being multiplied by t. So divide by that number. And whatever you do on one side, you do the same thing to the other side. But the reason we wanted to divide by the r is that r divided by r is 1. And 1 times t is just t. So we have t by itself. And it equals whatever the distance is divided by the rate. We know that this works because if we actually did some problems, let's suppose we traveled for 3 hours and we were traveling at 60 miles per hour. Well, if that were the case, this is our rate and this is our time. So our distance would equal our rate of 60 times our time of 3. Don't tell any science teachers I'm leaving off the units just so we can get through this quickly. Distance would equal 180. So in the end, we know that the distance is 180, and that equals the rate times the time. And if we wanted to get the time by itself, we would just divide by 60 on both sides, and that would give us our time. That would be distance divided by rate. Oh, so when we divide both sides by the rate, and we get 1 times whatever the time is, we assure ourselves that indeed this is the right relationship. That time would equal the distance divided by the rate. It would be 3 hours of time if we took our distance divided by this rate, but that gives us a general formula. One last one. This one's kind of tricky when you have to isolate a variable and there's a little bit more going on. So let's suppose this time we want to solve for L. So solve for L. So get L by itself, but let's investigate a little bit. There's a number being multiplied by L, and there's a number being added to L. Because W is a number, so W times 2 is some other number, so to get L by itself, reverse order of operations. We take care of addition first. We need to create the important number 0. We do that by subtracting 2W from this side. So what's left is we have P minus 2W. You know what? That's a variable expression, but P is some number, W is some number. So the result of P minus 2W, it's some number. All right? And so over here, what we're left with is just 2 times L. And by the way, L is a number. So, hey, there's what we have left. How do we get L by itself? We have to get rid of this number that's being multiplied by the L. So we divide by 2 on both sides, because 2L divided by 2 is going to give us just L. So what do we end up on this side? We divide everything on this side by 2 also. That P minus 2W, it's a number. We don't know what it is yet, but we'll divide it by 2, and that will give us the value of L. So our final answer, P minus 2W divided by 2 equals L. If you want to simplify it, you can, but you can leave it just like that. Literal equations, remember, variables are numbers.